Hello, grade 6. Today we begin chapter 1 in Nelson Math. Our getting started for patterns. Here are our goals. We're going to use models and tables to represent patterns, identify, extend, and create patterns, analyze, represent, and describe patterns, use patterns to solve problems. In other words, we're going to be building what you already know in terms of patterns to learn more about patterning and how it works. This is a bit of review from grades 5 and earlier. The question asks, write the next 3 numbers in each pattern. And here we have a number of different patterns. Let's begin with the first one. The first one's asking us 15, 30, 45, 60. By inspection, meaning just by looking at it, most of you have the pattern. However, I would encourage you to look at how the pattern is changing. So from 15 to 30, it increases by 15. From 30 to 45, it increases by 15. From 45 to 60, it increases by 15. So our pattern here indicates everything is increasing by 15. So 60 plus 15 is 75. 75 plus 15 is 90. And 90 plus 15 is 105. B, 144, 133, and so on. Once again, by inspection, you can see what it's doing. However, I would encourage you once again to look at what the pattern is doing in terms of increasing and or decreasing. From 144 to 133, it decreases by 11. Similarly, every new number decreases by 11. Therefore, we are going to continue the pattern of decreasing by 11. So 111 minus 11 is 100. 100 minus 11 is 89. And 89 minus 11 is 78. 1C. We start off at 1, 11, 111, 1111. You can see from this pattern, we are adding the next one more 1 to our previous number. So we're adding one more in our place value column. So for this one, 1111, it would be 11,111. And because of our comma here, I'm going to put a little dash. The next one is 111,111. And the next one is 1,111,111. You may also use the SI format, which would write the numbers like this, leaving a space after each period of 3 digits, starting from the right. This is also valid, so 11,111, and so on down the line. D, 2, 5, 9, 14. Let's look at how the pattern is changing. From 2 to 5, it's an increase of 3. From 5 to 9, it's an increase of 4. And from 9 to 14, it's an increase of 5. It appears that our pattern is increasing by the next integer. So plus 3, plus 4, plus 5. So our next one will be plus 6. 14 plus 6 is 20. Now we're going to add 7 for 27, and then add 8 for 35. And lastly, we have here E, 97, 88, 78, 67. Look at how the numbers are changing. So 97 minus something gives you 88, and that something is minus 9. From 88 to 87, 88 minus something gives you 78. That's a minus 10. 78 minus something gives you 67. That's a minus 11. It appears that we are decreasing by the next integer. So minus 9, minus 10, minus 11. The next one would be minus 12. So that's 55. Then minus 13, which is 42. And minus 14, which is 28. It is very important you look at and you do these calculations to make sure that you can see where you're heading. Describe each pattern in question 1 and write the pattern rules for parts A and B. I've already done this extensively when I actually did the question. So in words, for 1A, I am increasing by 15 every time. And for part B, I'm decreasing by 11 for every successive number in the pattern. Number 3, make the next design in this pattern. So the next design in this pattern I'm going to show on the next page. On this side of the page over here. So I've written the patterns as they are right now. So here's design 1, and that corresponds here, design 1, design 2, and design 3, And I counted each polygon. So in our first design right here, I have 1 green and 1 red. So that's why it's indicated 1 and 1. For our next design, I have 1, 2, 3 green and 1, 2 red. And that's where this comes in. And for our next design, it's 1, 2, 3, 4, 5 green and 1, 2, 3 red. So to continue to make this particular design for the next one, I'm going to do it all in one here. Notice that's what's happening to my green. I'm adding 2 every time, from 1 to 3 to 5. So for the next one, I would need 7 green polygons. For our red, we're increasing by 1 every time. So I have 1 in the first design, 2 in the second design, 3 in the third design, down the line. So this would be 4. So if I made design number 4, I would need 7 green and 4 red polygons. And we can continue for the green column for designs 5 and 6. I keep adding 2, so 9 and 11. And for my red, I'm always adding 1, so that's 5, and that's 6. So for number 3, this is the chart we would make, or we could have continued making it with the polygons in this case. And for C, how many of each shape are in design 6? If I made design 6, I would need 11 green pieces and 6 red pieces. Number 4. Grace planned a welcome back party for her friends. She made this table to decide how much food to order. Question A. How many bags of chips would she order for 18 people? So if she's planning it this way, she can see that if she has 3 people, she would need 1 pizza, 2 bags of chips, and 3 bottles of juice. 6 people, she goes from 1 pizza to 2 pizzas, 2 bags of chips to 4 bags of chips, and 3 bottles of juice to 6 bottles of juice. We can see from this chart that as she adds 3 more people to the party, she adds 1 more pizza, 2 more bags of chips, and 3 more bottles of juice. So let's continue with this pattern. So this is 9. We're going to keep adding 3. That's 12. That's 15 people. And that's 18 people. So for our number of pizzas, we add 1 every time. That's a number of pizzas. For a number of bags of chips, we're going to add 2 every time. And for our bottles of juice, we're going to add 3 every time. And we'll just center all of this. So now, this is how much of every item she would require. So how many bags of chips would she order for 18 people? That's right here in this column. So match up 18 people. And here would be our 12 bags of chips. Grace ordered 60 items. How many people were at the party? We can also look at this and add 1 more column and look at the sums. So if we were to look at, we could just look at 18. If we looked at 18, we could see that there were 18 bottles of juice, 12 bags of chips, 6 pizzas. Well, that's 18 plus 12 is 30, plus 6 is 36. So we know for sure there must have been more than 18 people at the party. We can keep adding. We can continue to stretch this chart out, and we can keep going. Add 3 people every time, add 1 pizza every time, add 2 bags of chips every time, or add and add 3 bottles of juice every time. But there is one thing you can do as well. You can look back and you can add up the previous ones. Take a look at this one, for example, for 15 people. For 15 people, she required 15 plus 10 plus 5. That's 30 items. So for 15 people, if she needed 30 items, 30 is half of 60. So 15 must be half the number of people who came to the party. So it must have been 30 people at the party and 10 pizzas. And we can keep doubling all of this all the way across. 20 bags of chips and 30 bottles of juice. This happens to fit exactly with our pattern here. If we continued it, we skipped 21 people, 24 people, and 27 people. That would have also been a valid way of doing this question. But now we can check. 10 plus 20 plus 30 is 60. So that's how many people were at the party. 30 people and 60 items. Thanks, everyone. Have a good day.